In the vast, uncharted realms of the cosmos, even the slightest aberration can reshape our understanding of the universe. 2 nights ago, an event transpired that sent shockwaves through every major observatory on Earth, leaving scientists baffled and the world captivated. The interstellar object 3I Atlas, a traveler from beyond our solar system, suddenly brightened with a dazzling intensity that defied all known celestial phenomena. This celestial spectacle, which began as a quiet anomaly noticed by an amateur astronomer in a small town in Germany, was soon confirmed by observers across continents. Maria Schultz, a dedicated amateur astronomer, observed 3I Atlas through her 12-inch telescope, and her software flagged an anomaly. A sudden vertical leap in brightness, 1.4 magnitudes higher than before, sustained for 6 full minutes. Initially, she assumed it was a glitch, but upon checking her calibration stars, equipment, and even atmospheric data, everything was found to be perfect. Within 30 minutes, observers in New Zealand, Arizona, and Brazil began posting identical results. The light curve was impossible. Not sinusoidal, not periodic, just a flat line that suddenly jumped like a heartbeat and then held steady. No comet, asteroid, or fragment had ever behaved this way. By comparison, the legendary outburst of Comet 17 Peace/Holmes in 2007 took nearly 2 days to brighten by a similar magnitude. What Schultz saw happened in less than 1% of that time. By midnight, the hashtag #AtlasAnomaly was trending worldwide, and within hours the global astronomy community was awake, staring at the same question. What could possibly cause such a clean, instantaneous burst of light? As word spread, a chain reaction swept across the globe. Forums and Discord servers filled with overlapping screenshots, exposure logs and light curves all matching down to the minute. Citizen science platforms like Skywatch Collective went into overdrive, confirming the anomaly across 4 continents. It wasn't a hoax, nor an equipment malfunction. By dawn in Europe, professional observatories were on alert. The Pan-STARRS and Atlas survey telescopes confirmed the spike, as did robotic telescopes operated in Chile and Japan. Data streamed into a growing public repository, a digital relay of humanity's curiosity. But then something strange happened. The professionals took over. The Deep Space Network interrupted routine Mars telemetry, rerouting its 70-meter dishes toward the coordinates of 3I Atlas. Engineers voted unanimously to override standard scheduling, sacrificing data from missions like Perseverance and Voyager to capture radar reflections from a single interstellar visitor. The decision cost them 22 hours of lost mission time, a move reserved only for life-threatening asteroid flybys. Yet this wasn't an impact threat. It was a light anomaly, and still, the world's most powerful antennas turned their gaze toward one point in the sky, as if every nation sensed that something extraordinary was unfolding above. The global coordination didn't stop there. By the following morning, the Very Large Telescope in Chile, Gemini North in Hawaii, and even China's Fast Radio Telescope had all dropped their planned targets, redirecting every instrument to 3I Atlas. The IAU voted 8-2 in favor of a planetary-scale observing campaign, a rare act of unity in a field often divided by funding and competition. For 48 hours, humanity's finest instruments watched the same object. And then, silence. The same astronomers who had been posting hourly updates on social media suddenly disappeared. Private research chats went quiet. No new data appeared on preprint servers. No press statements, no leaks, nothing. Analysts tracking social media activity reported a 70% drop in communication from verified astronomers who had previously discussed the event. Something had changed behind closed doors. Even the few automated logs that trickled out painted an eerie picture. Radar signals showing a non-gravitational acceleration 4 times stronger than expected. An infrared plateau, 30 Kelvin above normal, and faint bursts of gamma radiation at 3I Atlas's exact coordinates. None of it made sense, and yet all of it was real. Within 2 days, the anomaly had transformed into a full-scale mystery. The Mars orbiters confirmed the same infrared excess, despite being millions of kilometers away. Ground-based telescopes recorded the same acceleration, and deep space antennas detected faint echoes that seemed to pulse at regular intervals. But the most haunting detail wasn't in the data. It was in the reaction. Astronomers who had spent their careers chasing comets and asteroids now refused interviews. Entire observatories were locked into silent mode, citing data verification. The IAU's internal report, leaked by an anonymous insider, described the situation as a synchronized global anomaly, requiring immediate containment. No other words, no public explanation, just a note that all assets are to maintain continuous observation until further notice. For the first time in modern history, every eye on Earth was focused on one object from another star system, an object that, in a matter of hours, had forced humanity to rewrite its definition of what's natural and what's not. Then came the discovery that changed everything. Using differential imaging from the James Webb Space Telescope, researchers noticed a secondary object, smaller, colder, and perfectly aligned with 3I Atlas's trajectory. At first, they thought it was a fragment or a dust cloud, but over successive scans, the secondary body maintained a fixed distance of 120 kilometers and moved in precise synchronization with the primary object. It wasn't drifting, it was orbiting. The discovery sent shockwaves through the IAU's emergency channel. A natural object with a companion that close would be gravitationally unstable, yet this pair moved flawlessly, locked together as if bound by invisible control. Even more baffling was the secondary body's spectral signature. It reflected almost no sunlight, but emitted faint microwave radiation consistent with active heat dissipation. In other words, it was regulating its temperature. By now, most astronomers had stopped using the term comet. The official designation changed quietly from 3I Atlas C2025R2 to 3I Atlas Complex. The word complex was no mistake. It was a silent admission that the object was more than one thing, and possibly more than just matter. Everything came to a head when 3I Atlas reached a position known as nodal alignment, the point where its orbital plane intersected Earth's. At that moment, every telescope, radio dish, and orbital observatory trained on it simultaneously registered a surge in intensity. The pulse frequency increased, the secondary companion brightened, and the region surrounding both objects filled with a faint halo visible even to amateur astronomers. It wasn't sunlight, it was internal luminescence, energy being released from within the structure itself. The James Webb Telescope recorded diffraction spikes consistent with geometric edges, not random debris. The object was unfolding. Spectrographic analysis showed a temperature drop of 60 Kelvin, suggesting that energy was being redirected inward. And then, the impossible happened. For the first time, 3I Atlas emitted a directed radio beam, focused and narrow, aimed precisely at Earth's ecliptic coordinates. The signal was brief, only 12 seconds long, but it wasn't noise. It carried structure, patterns, and harmonic symmetry far beyond any natural process. Within minutes, the transmission stopped, the light dimmed, the pulse vanished. 3I Atlas went silent once more, leaving behind one haunting question echoing across every observatory. Who was listening on the other side? For days, the world waited for an explanation. The directed beam from 3I Atlas had lasted only 12 seconds, but its echoes were still being analysed by observatories across the planet. Then, quietly, one team broke the silence. The Square Kilometre Array Observatory in Australia. Using its massive radio network, they reconstructed the full waveform of the transmission, expecting it to reveal nothing more than background radiation. Instead, what they found stunned them. The beam wasn't random. It contained a harmonic structure built around the same 247-second pulse that had haunted astronomers for months. Embedded within that pattern were frequency ratios identical to those found in hydrogen spectral lines, the universal constant of communication. Hydrogen is everywhere, the cosmic alphabet of existence. Whoever or whatever generated that signal had chosen the one frequency every civilization capable of science would understand. But the real shock came when the data was translated into visual form. The waveform, when converted into a spectrogram, revealed a repeating geometric pattern. 6 perfect hexagons spiraling outward around a single point of light. It was a mirror image of the James Webb Telescope's final images of the 3I Atlas complex, the object and its companion locked together in formation. The transmission wasn't just a signal, it was a blueprint. And that blueprint, when rendered in 3-dimensional mapping, corresponded almost perfectly to the orbital architecture of our own solar system. Each hexagon represented an orbital resonance point, a harmonic alignment between planets, with one glaring difference. At the center wasn't the sun. It was empty, precisely positioned where 3I Atlas now drifted. Scientists were divided. Some said it was coincidence, an interstellar echo that our pattern-hungry minds turned into meaning. Others, like Harvard's Avi Loeb, called it something else, a synchronization event. According to his paper, the signal's purpose wasn't to communicate in the traditional sense. It was to tune something, a calibration sequence between the object and the solar system itself, as though it had locked on to our gravitational rhythm and adjusted accordingly. Loeb compared it to a musician tuning an instrument before playing. If that's true, then the 12-second signal wasn't the message. It was the test tone before the real transmission. Then another revelation hit. As the data spread across institutions, analysts noticed that Earth's own magnetic field had fluctuated precisely 12 seconds after the beam ended. The same pulse, the same interval echoed through our atmosphere, briefly altering the ionospheric resonance, the Schumann frequency, by 0.02 Hz. To most, it was meaningless. But to those studying the event, it was confirmation that the transmission had interacted with Earth directly. For a fleeting moment, 3I Atlas had reached across 300 million kilometers of space and touched the planet. The official statements were predictable. Instrumental errors, solar interference, data reclassification. But behind closed doors, Project Helios, a task force formed by the International Asteroid Warning Network, concluded something that was never made public. The directed beam wasn't a random transmission. It was a response. When the first amateur telescopes detected the brightness anomaly weeks earlier, Earth had unknowingly emitted its own faint electromagnetic noise back into the cosmos. 3I Atlas hadn't simply appeared brighter. It had been illuminating us back, and now, silence. No pulse, no gamma spikes, no acceleration. The interstellar traveller drifts beyond Mars, silent and watchful. The data classified, the world moves on. But among the astronomers who first saw the 247-second rhythm, one question remains. What happens when that frequency returns? What if the next signal isn't light, but something else? Because maybe 3I Atlas never came to visit. Maybe it came to synchronize. So if this story made you question what's really happening out there, don't look away. Subscribe to this channel. We uncover what the rest of the world is too afraid to discuss. Turn on notifications, because when the signal returns, and it will return, you'll want to be here to hear it. In the following weeks, researchers and scientists around the world continued to analyze the data collected during the 48-hour observation campaign. They studied the light curves, the radar measurements, the spectroscopic data, and the radio transmissions, seeking answers to the questions that had been raised by the appearance of 3I Atlas. Some teams focused on the object itself, trying to understand its composition, its structure, and its origin. Others focused on the secondary object, the smaller body that was orbiting it, trying to determine its nature and its role in the overall system. One team, led by Dr. Sarah Williams at the European Southern Observatory, spent countless hours examining the light curves of 3I Atlas. They noticed something unusual about the way the object brightened and dimmed. It didn't follow the typical patterns of a comet or an asteroid. Instead, it seemed to have multiple components, each with its own emission characteristics. This suggested that 3I Atlas wasn't a single object, but a complex system composed of multiple parts. Another team, led by Dr. John Anderson at NASA's Jet Propulsion Laboratory, studied the radar measurements of 3I Atlas. They found that the object was not only emitting radio waves, but it was also reflecting radar signals in a way that indicated the presence of a rough surface. This led them to hypothesize that 3I Atlas might be made up of a collection of smaller objects, or fragments, that were held together by some kind of force. Dr. Avi Loeb, a theoretical physicist at Harvard University, took a different approach. He focused on the radio transmission itself, trying to understand its structure and its meaning. Using the data collected by the Square Kilometre Array Observatory, he was able to reconstruct the waveform of the signal, and he found that it contained a series of repeating patterns. These patterns, he argued, were not random, but they followed a mathematical sequence that was consistent with a self-similar fractal structure. This led him to hypothesize that 3I Atlas might be a self-replicating machine, sent out from a distant civilization to explore the universe. While some scientists were captivated by the potential implications of Loeb's hypothesis, others were skeptical. They argued that there was no evidence to support the idea that 3I Atlas was a machine, and that it was more likely to be a natural object, perhaps a comet or an asteroid with unusual properties. They pointed out that there were many natural processes that could produce the kind of light curves and radio emissions that had been observed, and that it was premature to jump to conclusions about the object's origin. As the debate raged on, the IIU announced that it would be holding a special meeting to discuss the 3I Atlas anomaly. The meeting, which was scheduled for later that month, would bring together some of the world's leading experts on comets, asteroids and radio astronomy to discuss the findings and to propose solutions to the puzzle of 3I Atlas. In the meantime, amateur astronomers continued to observe the object, hoping to catch another glimpse of the mysterious interloper from beyond our solar system. The days leading up to the IAU meeting were filled with anticipation and excitement. Scientists from all over the world gathered in a large conference hall, ready to share their ideas and their findings about 3I Atlas. The meeting was chaired by Dr. Maria Schultz, the amateur astronomer who had first noticed the anomaly, and who had since become a central figure in the 3I Atlas saga. Over the course of 3 days, the scientists presented their findings, debated the implications, and tried to make sense of the strange object that had captured the world's attention. Some proposed theories about the object's origin, while others focused on its structure and composition. There were discussions about the radio transmission, the light curves and the radar measurements, and there were debates about the significance of each piece of data. In the end, the meeting produced more questions than answers. The scientists were unable to reach a consensus about the nature of 3I Atlas, and they were divided about its origin and its purpose. Some argued that it was a natural object, perhaps a comet or an asteroid with unusual properties, while others maintained that it was a machine, sent out from a distant civilization to explore the universe. In the weeks and months that followed, the debate continued, both within the scientific community and among the general public. Some people were captivated by the possibility that 3I Atlas was a sign of intelligent life beyond our planet, while others were skeptical, arguing that there was no evidence to support such a claim. Meanwhile, the observations of 3I Atlas continued, as astronomers around the world monitored its movements and its emissions. The object was now known to be on a trajectory that would take it out of our solar system, never to return. But for many, the mystery of 3I Atlas would endure, a reminder of the mysteries that still lurk in the vast expanse of space, waiting to be uncovered. As the years passed, the 3I Atlas saga faded from the headlines, but the questions it raised remained. Did the object come from a distant civilization, or was it a natural phenomenon with unusual properties? What was the nature of the radio transmission, and what did it mean? And most importantly, what did the appearance of 3I Atlas tell us about our place in the universe, and our role as observers and explorers? For many scientists, the 3I Atlas anomaly was a reminder of the power of curiosity, and the importance of continuing to explore and to question. It was a reminder that the universe is a vast and mysterious place, filled with secrets that are waiting to be discovered. And it was a reminder that, as long as we continue to ask questions and to seek answers, there will always be new mysteries to uncover, new worlds to explore, and new horizons to cross. In the end, the 3I Atlas saga was more than just a story about a strange object that appeared in our skies. It was a story about the human spirit and our insatiable desire to understand the world around us. It was a story about the power of curiosity and the importance of never giving up, no matter how challenging the journey may be. And it was a story about the boundless potential of the human mind and the incredible things that we can achieve when we dare to dream and to reach for the stars.